Thanks so much for coming. I really appreciate it. I know it's late, and so I hope to keep you awake for the next 45 minutes to an hour. It's a bit too bright. Anyway, so I'm going to be talking about the title of my talk is The Science of Faith and Doubt. Now you'll notice that it's presented by two people. So it's a bit of a confusing way to start since there really is only one person standing in front of you. But I'm here to argue that there actually is two of me. I am Stephen Joach, and I also am Sid Sledge. And the reason I can be two people is because is that I've had really two lives so far. The first was as a scientist. I worked from 1998 to 2008 as a scientist working in genetics. And then I had this transition into becoming an artist. I think I was just feeling frustrated with the way science was going, and I just needed almost to get back to basics using simple materials, so I reinvented myself, and that coincided with when I moved from South Africa to Sydney. So then I just decided to call myself Sid Sledge. It's not based on completely a whim. I made this character when I was like 13, 12, and it made me feel very brave to say I'm Sid Sledge. So I thought, well, let me just bring him back because I need to feel a bit brave now for the next couple of years while I work out what is this thing called an artist. It was an amazing opportunity. So that's what I did. I just basically did that, and it's a bit of a journey which I will be talking to you about. But what's really quite interesting about it is it took my life as an artist to really help me appreciate and understand the sciences for me and what they really meant to me, and also the deep sort of kind of underlying spiritual place that they touch on, which is why there's a bit of faith and doubt there. And in my summary, I talk about my obsession with Genesis. Like, I've tried to read the Bible and I can never really get past the story of Genesis because I find it so fascinating. And I noted that there's this amazing parallel between science and between Genesis. And basically it took the artist Sid Sledge to inform me about what that parallel was. So that's really what I'm going to be talking about today. So this goes back many years to when I was growing up in South Africa, and obviously you all know about apartheid. It was a bit of an oppressive place. I mean, as a kid growing up was wonderful, to be totally honest. I had a wonderful life, but I guess the zeitgeist was quite oppressive, a bit black and white, to forgive that expression, and everything was as it was. There seemed to be no surprises. I wasn't aware of any of that. I was a happy kid growing up. But then when I had my bar mitzvah, I had a bit of an epiphany. I was given this book. It wasn't the Bible. I suppose it should have been the Bible given that it was by bar mitzvah, but it wasn't. It was this book called Life on Earth by David Attenborough. It's this beautiful illustrated book called Life on Earth. And I would page through that, and there's these incredible images of what prehistoric life might have looked like 50 million years ago, 100 million years ago. And a bit like Jerry Seinfeld, the back of my head exploded right off, and I saw these images, and I thought, the world isn't actually as it is. It's a very magical and mysterious place, and I want to know about that world. So that's really set me off on my track to becoming a scientist, and specifically in the field of genetics. So basically, while preparing this talk, I had to think about what really is science in a nutshell. And it really is our need to order the universe, to make some sense of our place in the universe, and really to try and identify patterns. That's really a key word in this talk, this word patterns. Try and identify those things that relate from one area of science to another area of science that seem so disparate, but they are. We need to try and identify those patterns. That is what science is. And so it's a journey from chaos to order, from an unknown to a known. Same, I'm trying to laser point, but it's not happening. Same with Genesis. Genesis really is, and I'll go into that a little bit later, but it really is that story about how we go from this formless void, to where there's just water, into this amazing, structured, ordered universe. And that's the story of Genesis. And it's an incredible document about how we manage to structure our world, make sense of it. So just to kind of get to the sciences now, talking about patterns, my area of specialization was genetics, and I studied viruses. And basically, on the top left there are just a few different kinds of viruses, 200 nanometers wide, in other words, very small. If you incredibly small. Basically, you have to use an electron microscope to see them. But what is really interesting about these structures, if you blow up an image of a virus, any one of those viruses there, you'll essentially get that on the right there, a dandelion, okay? So, and it's not trivial, these similarities. There really is, in the way things self-organize and get together as objects and structures, patterns. And that's a classic example. And I use another example of a pattern. There's a tobacco mosaic virus, bottom on the left. And if you blow that up about 1 million times, you get a milli. Sorry, and that's corn. So the African word for milli is corn, or the other way around. So that's really the same thing. They've got the same structure, the same arrangement of building blocks that give rise to these structures. Their building blocks in the virus might be much, much simpler, but it's the same idea. So I'm currently reading this book called Colliding Worlds, and it's really how artists use science, right? It's an amazing book actually by Arthur Miller, and not the one who wrote the other books. Thank you, yeah. So, but there's on the cover of this book is this sculpture. It's a big glass sculpture called I can't remember what it's called. It's called The End of Modernity, but really it's a sculpture, a glass sculpture of the universe at inception, and using some quite deep scientific ideas, showing the Big Bang and showing the emergence of galaxies and smaller structures, and within that smaller structures. Now, when I used to teach about viruses to my students, I've always shown them a figure like that, and that's to me the same figure, but yet that is talking about how viruses evolve, how rapidly evolving like viruses like HIV, how they come to populate and how they change, and how they emerge from a single thing to become many things. It's the same core idea, a pattern between very different disciplines and areas of thought. I have my favorite molecule here, just to quickly show you. That's DNA. I mean, it really is a mind-blowing thing that this incredibly important molecule also happens to have this amazingly beautiful structure, a double helix. I mean, you couldn't think that up. And basically, when Watson Crick and Rosalind Franklin solved that structure in 1953, they could immediately look at that, and the logic of it was absolutely clear. They could work out by just looking at it how this actually worked, how it gave rise to all the properties of genetics, replication, storing information, transmitting information, all there because of the way it looks. So the incredible logic in this structure, which is really quite a remarkable thing. But having said that, I became frustrated with this way of I think what actually happened, if I'm going to be specific, it became a very technological world, science, and I just really, to be totally honest with you, didn't enjoy, I wanted hands-on, I wanted to use my hands again, and I felt that to do science, it was very technological, it just wasn't what I needed at that time. So I gave way to Sid Sledge, as that arrow indicates in the bottom, and I basically set about on this journey into art. And to do that, I really had to say to myself, okay, I think too much, so I'm going to try not to think for a couple of years and see what happens. So I go around the city with my paintbrush and my easel, and I basically paint colorful pictures, trying to work out color, line, composition, all these things. These are on the streets of Maroubra, where I live. This is in Paddington. I'm going to run through these quite quickly. I mean, a word that actually came to me the other day when I looked at that, and it's not chaos. These paintings are not chaos, but they're definitely looking at a sort of, the forms are not, not totally clear. And I think that's interesting for me because it mirrors what later became of my art in an interesting way. This is in Bondi, in Johannesburg in South Africa. I would paint on the streets there, and this is a township outside Pretoria. This is outside a window in Cape Town. So you can see very colourful, and I was really just looking for colour and trying to understand those things. In Hyderabad in India, where we spent a little bit of time, painted there too. So really this is a bazaar in India, a very busy bazaar where I was painting, which was a lot of fun. But that's what I was doing, and I thought, okay, I've worked this all out, I just need to keep doing this and then it'll just be fine. But what happened was, as things do come up from the subconscious from time to time, I was having a conversation with my wife. It was quite a heated conversation, but as one does, because it's what you do. And I was doodling because I have a notebook and I doodle all the time. So basically, I'm having this heated conversation, and after the conversation, it resolved nicely, I must just say. I looked down at my notebook and I'd done this doodle totally subconsciously. And I took one look at it and I thought, I've actually just sort of managed to map out the rest of my artistic journey in this one doodle. Because what I'd done subconsciously was I brought back the world of ideas. They just came flooding right back in. They tired of me being this flighty artist. They wanted to get back into the picture. And what is really quite something is when you realize, oh, I'm going to be dealing with ideas, you also just notice that ideas are also beautiful things. They are an aesthetic. They have their own aesthetic. Could be symmetry, could be simplicity, could be complexity. But they have something which ties in. A beautiful idea is a beautiful thing. If you look at scientific data, it can be exquisite. Like just to look at a graph. Get very excited to see a nice graph. That might just be me though. I mean, what I've done, just to talk about this figure a little bit, is that I turned the DNA into a stem of a plant and was somehow rooted in the mouth of a fish. So it doesn't mean anything necessarily, but I could realize, oh, it's pointing somewhere. It's trying to go somewhere. I'd fiddled around with the surfaces, so the fish had come the water. So I realized, okay, there's something going on here, and I need to keep exploring it. I'd reimagine myself while arguing with my wife as a tree, evolving. So I'd reimagine my own evolution. I'm thinking, why can't we evolve? Why do we evolve into these sentient beings that walk around? Why didn't we just get roots and just be like that, you know? Parking wouldn't be such a problem if it was that way. So this really kind of said, okay, this is what I'm about. This is what I need to now focus on. So I did several drawings, and I eventually came, and you'll notice also the medium had become much simpler. I was just using ink, and very simple, because I realized ideas are just really, they don't have to be, you don't have to throw a lot of color at them. They have their own aesthetic, so I'm going to focus on that. So this was a drawing, which I did in 2014, so not too long ago, but still the boats, but what became very clear as I was doing this is that I basically stumbled on these things which I call boat building blocks. So basically I rediscovered my science again in a way. I was making molecules, and I was using a structured way to get into my art. And what was really important about these boat building blocks is they have a lot of rules. They are rule-based things. There's no randomness anymore. There's no chaos, let's say. But I have to follow the rules that these boats dictate to me. And I found that for some reason very exciting. Like, I thought, this is really exciting. I want to now start exploring what these things are. So I started using that kind of method on the streets of Sydney. And I think this is one of the better examples of it, is where I just was using these boat building blocks. And I came to think of them as almost like a universal DNA, like a universal architecture that basically links the road to the car, to the child, to the mother, to the car, to the buildings. It was this thing which kind of broke down those barriers between things and basically unified the work for me. And I loved that idea. But the important thing that I realized was that I could now start doing art, but asking science questions, asking questions as a researcher would ask them. So not think of myself as an artist, think of myself as a researcher trying to understand this phenomenon which I created. So that's what I set out to do. I call it my Genesis pang as well, because in a funny way, I come upon structure. And I think if you're a primitive being, or when you're trying to work out your place in the world, when you stumble upon those patterns, those early beginnings of structure, it must be quite not satisfying, but it must give you a feeling of like you're on something solid. And it's quite, I think that's what happened to me. So this is really an exploration of these boat building blocks, right? So that's got quite abstract, but I don't see it as abstract because it really is all about those boats and the patterns they form. And so the scientific question I asked was, what happens if you proliferate these boats one at a time, top to bottom, in the absence of lines, in the absence of things that are going to give them kind of holding? And what really excites me about this sort of thing is I'm just following the rules of the boats now. I'm not saying I want a picture that's going to have a nice big bulge over here and I want those things to go in. I'm following the rules dictated to me by my boats. And as a result, you get this effect. And I don't know if I said earlier, but what really excites me is that, you know, when you start asking questions like this, it seems to allude to real world phenomena that you see in nature. And the phenomena that I got excited about was, I see early on something called the butterfly effect. If I make a mistake, not a mistake, but I'm just zooming in over there on that slide. If I'm in the studio, my back's a bit sore, I'm shouting at the children while I'm trying to do a boat, the picture goes a bit, it loses it becomes plastic, the boats are skewed, simply, just not putting them on accurately. That has a consequence much later on. So this big bulge here is because it has to accommodate that slight bend made early on. So that I found was very exciting. And further to that, it also touched on, for me, an important discussion in this talk about structure is this idea of uncertainty. I like things, and I think it's important, when things become too structured, they become a bit uninteresting. But when there's an element of uncertainty which kind of drives the evolution, you're dealing with an interesting system. And that's really going to become the crux of what I'm going to talk about as we progress. How are we doing for time?
Good.
All right, good. Now, this is a similar experiment, but now, and I'm calling them experiments now, this is data. This is what happens when you radiate boats on rigid lines. Very symmetrical, very ordered work. What you gain, I mean, you get, I think, a beautiful result, but what is interesting about it, compared to the previous image, is that it's predictable. There's a what I call low information. So in an interesting system, you can get very complex in patterns and information emerging as a consequence. Here, we know what it's going to look like at the beginning of the work and to the end of the work. So that is a consequence of too much structure, if you ask me. All right. So that's just something to keep in mind for later. That's on radiating straight lines, and that's on wavy lines, and that's just what it does. This is one which radiating boats. This is where the boats dictate the line, and then the line dictates the boat. So there's an interdependence, and so it also has a little bit of that idea of uncertainty, and the resulting work will be unpredictable. And I like things that are unpredictable. They are more interesting. So that pretty much ends the discussion of. It's an ongoing thing, exploring these boats, but that's where you are at the moment. Just to quickly summarize, the top two, there's a bit of uncertainty, there's a bit of variation allowed to come in, so it's more, to me, a more interesting result. And those are much more rigid, and as a result, more structured and less information about them, less that can really happen. Right, so, as I said to you earlier, I have a bit of an obsession with the story of Genesis. And absolutely, in particular, without a question, the 5th day of creation excites me the most. Because that's the day the fish and the birds were created. Now, you haven't seen these slides, but I always painted and drew fishes and birds. It was an obsession of mine. I was a lousy student at school, so I didn't pay attention in Bible studies when would have told me that on the 5th day they made fish and birds. So when I read this as an adult of 42, I was running around the house saying, "Did you know that?" And I'm like, "Yeah, it's in the Bible, first page." So anyway, I was terribly excited by the story, and I wanted to explore something around that idea of the fish and birds, and you'll see why later on. This is just to really repeat, as you know, Genesis being that march from order to order. There's just the formless void. The land and water emerging being the first kind of nucleation point where structure can start to happen. Animals, fish and birds and people start to get populated, start to add more structure to this universe. And then Adam and Eve, and then naming the animals. So what's really happening here? So this is the thing that's really important to me, is that as we kind of get more specialized, and that's really what's happening, we start to compartmentalize things a lot. You see a child, they don't know all these partitions and they see the world very differently. But we start to partition enormously, we specialize, we over-specialize, and we lose, I think that we lose something by doing that. And one of the things I thought I could do as an artist is to try and see if I could basically return things to a more primal state. Like I wanted to go back, get rid of some of these seams that are separating things in our universe. That became, I thought I could, as an artist, I could do that. As a scientist, you get into a bit of trouble because what I wanted to do was basically return the fish, which were made on the 5th day, to the bird. I wanted to bring them back together again. And that sounds to me like a genetic problem, right? That's a problem of genetics, not art, genetics. Before I discovered my boats and all these things were adding structure to my work, I was asking questions more like this. I'm imagining God or one of his angels being a sculptor in his prehistoric lab, chiseling away, making fish and bird forms, which you can see in the cupboard over there. Outside the window is this formless void. So that's this creature here is either, I'm not saying that's God, but it's probably one of his angels. But it's a bit of a fishy bird kind of creature. Like, I think some interesting things must have happened on that day God made the fish and the birds. You know, I don't think it was just cut and dry. This is another depiction of that day where you have this strange fish-bird entity kind of negotiating with the sculpture that it's making about how it's going to unfold. And that sculpture in turn is dictating or influencing what's happening in the world outside of it today. Which I thought is interesting as well because this ongoing idea of creation is an ongoing thing. But it's a bit of a distraction because I wanted to get back to my genetics. This is another kind of slight aside because while preparing for this talk I discovered Escher, who is someone I greatly admire. He also has a thing for the 5th day of creation. There's his fish and birds being created, and there's a more kind of molecular idea around the evolution of fish and birds and immersion, very specific bonds as well, interactions, kind of like what I'm doing. Difference is, he's a mathematician as far as I'm concerned. He's all about precision. I stay away from too much precision because I'm interested in the other kind of more biological way of thinking about these things. But he is extremely precise. Now, so, I know it's late, 9:15. I don't expect you to follow this slide exactly, but I wanted to show you that in scientific discourse there are algorithms, there are rules that you follow to understand a process. This is the rule of genetic reproduction essentially, meiosis. When the gametes, the egg and the sperm get ready, they have to basically halve their DNA content, and basically there's the mom, there's the dad, there's half the amount of DNA from the original cell on top, and they've got to fuse them to return it to the original concept. So I decided, can I do that with my fish and bird? Can I treat them somehow as genetic entities? Now it was around that time that I went to the Museum of Contemporary Art and there was the Chuck Close exhibition, and it had a huge influence on me. Only later did I realize how I could use it. And basically what I did was, I realized I could pretend, because now I'm an artist, I can pretend, I don't have to get funding for these experiments. I'm going to pretend that every one of those, I'm going to grid my fish and my bird drawings, and I'm going to pretend that every one of those positions is a gene. And I'm going to swap every gene from a fish with every gene from a bird, so we get a hybrid, a perfect hybrid of a fish and a bird. So that's the experiment I set out to do. And essentially that's what you have on the left-hand side here, is a bird that's also been reduced, it's half bird, 50% bird. So I've removed every alternate bit of the bird and I've put it in the central panel. I've done the same with a fish over there, removed every alternate gene and put it in the central panel. And what you have in the middle there is a perfect genetic hybrid of a fish and a bird. 50% fish, 50% bird. I don't know if it's viable, I don't know if it swims or flies, but what I do like about it is it was so methodical, but also that it has its own kind of language. It's very structured, but it's also quite free on some level. And when you look at it, you can sometimes see fishiness, and sometimes you can see burniness, and it's all an interesting story. So that's the first attempt to use genetics in my art, and I found that to be quite exciting. Now, I was really getting ahead of myself, and I thought, okay, you can do this with fish and birds. Can you cross other things? So I said, well, why don't you just take a grid? Forget about the fish and the bird, just take a grid and see if you can cross it. But grids, black and white grids like a chessboard are really, let's face it, a little bit boring. They're not that interesting. So what I did was I turned to see what would happen. I created waves. I decided to use the idea of waves. So that would just really be changing periods. Let's not get too into that, but it's essentially you widen the gap and eventually the line, every alternate line eventually catches up with a line on top. Just like waves, and you get positive and you get negative interference. So I said, okay, let me now basically use those patterns over over the grid, essentially as I've done before, and do a genetic cross of the two grids. You'll notice they are alternating, so the top left is white and the top left is that. Informing my story to call it noisy, let's maybe say that.
It's called that, you can't tell where it's going.
You can't quite see where it's going, or maybe you can. But there, I've just kind of zoomed in on it. I don't know if you, it's what I like about it. It also has what I call a fractal quality, because the wave patterns that are sort of happening over here are also happening on that scale. So it's fractal in that the same phenomenon is repeated on different scales. But I think it is interesting how when you take one idea, this genetics idea in science, and mix it together with another idea in science, you get this phenomena which is occurring. And so as a way of doing art and asking questions about science, it seems to be pointing in an interesting direction. And it's making something my brain could not have conjured. And would love to have conjured, because it's a bit obsessed with the idea of chaos moving to order. Alright, so look, there's a lot of text over there, and my brother-in-law informed me tonight that if it's a TED Talk, there should be no text whatsoever. So I ask you to ignore that text, but just imagine. So now, I'm going to run through this next bit quickly. No, but really, basically what I'm trying to say is, again, I guess I'm playing, I want to still explore the idea of fusing a fish and a bird some more. I wasn't done with that, but I felt the genetics part was mostly done. I thought what would happen using these grids if I let a breeze, like basically a breeze floating over with fish and bird bits, dropping these fish and bird bits onto grids. What would that fusion look like of fish and bird? Would that be more interesting than a disciplined genetic cross? So it's an early experiment. There will be more to come, but this is essentially what happens if you let basically fish and bird molecules fall down onto these grids. That's on the top left is basically full fish, so there's no randomness there. That's predetermined. Bottom is also full fish. But as you move down, you get less and less fish basically placed there. And as you move across the top, you also get less and less bird being deposited there. But what I like about that is it's randomly determined. I haven't made any decision about where to put my fish bit or my bird bit on the top there, or the fish bit at the bottom. I've let randomness determine it. And that excites me. I don't know if it excites you, but it excites me. And then in the middle, in the central panel, I basically allowed the fish and the birds to mix with each other. So I'm using genetics, but in a very different, I'm pretending that genetics is operated by clouds. That's perfectly feasible. Don't you think? What's that?
How did you do that?
Oh, just basically, I rolled the dice. I basically took beads. Yeah, I used a randomized way of doing it. So that's really what I'm trying to do. And what I'm trying to look for is the optimal expression of fish and birds in these central panels. Now, there would be hundreds of thousands of millions of combinations possible. I'm only looking at a few. I took out the central slide. Yeah. So basically, what you can see there is in that next row where you have a lot of bird, a little bit of fish. So unsurprisingly, looks more like a bird. If you have 50% fish and bird, like that one over there, it starts to look like you're seeing both properties. This is something that's going to ongo, but this is just playing with the idea of using these clouds to deposit the fish and bird genes. Alright, so basically what I'm going to talk about now, actually coming quite close to the end, is this idea. I basically want to focus more, because I realized what was happening was the most interesting thing I was talking about or looking at was this idea of moving from a chaotic, sort of noisy part to a very structured part. It was that interface between chaos and order, which I was particularly interested in with this next work. And I used Genesis as the starting point because it really talks in a very simple way about moving from chaos to order. But later on, after having done a bit of research, the book of Job is an interesting book because it really is talking about the same idea as in Genesis, but it's basically saying, because obviously Job's life did not turn out very well, and the moral of that story is you actually need that uncertainty, that chaos, that unpredictability, the good, the bad, all those things interacting in a way to actually get properties to emerge like creativity, morality, excellence in things, to be an interesting system. Otherwise things are predictable. The patterns are too strict. And that's kind of what I was alluding to earlier on with the earlier slides. When there's variation in the patterns and when there's unpredictability, your result is more interesting. There can be more interesting patterns emerging, and that's what I was really interested in. So, and I'll just say that all living things actually exist at this interface. Societies, people, if you're too structured, this is a big field of science, this is not my own ideas, but basically things that are too structured are too rigid, they can't be sustained. Things that go over the edge, that are chaotic, cannot be sustained. It's that delicate interface between order and chaos which is of interest. That's the area where all the magic happens, really. So that's what I wanted to explore. So basically what I tried to do was imagine these my ordered boats moving across to more chaotic, more freedom-loving birds in a drawing. And remember that so this is an ongoing artwork which I'm basically working on. In fact, I was working on it outside earlier today. You may or may not have seen me. But basically what is interesting about this system and why it really touches on systems in the real world is that the boats are very rigid. They have very specific rules of interaction. They don't allow flexibility. This is true in the best system I can use to describe it, that's an analogy, is a crystal, when you make crystals. The bonds between the crystals are extremely rigid and they don't allow, there's no room for error. The rules of interaction are strictly determined. But as that crystal moves across into the liquid phase, when you put it in water and it starts to dissolve, when it enters the water, it's completely chaotic. The molecules are too far apart to see each other, to talk to each other. But it's that phase of going from the very structured boats where you're transitioning into the chaotic realm, where you go through this period, and I've used birds to basically, as a metaphor for that, and allow them to relax the rules of interaction. The key thing is that they are still touching. They still have to maintain some sort of contact, and once that contact is lost, you have basically, you go into the chaos realm. So this is an exploration of that. And I'll just zoom in a little bit so you can see more clearly. You can see the boats in a very transitional way, in a very stepwise way, changing into birds. And as they change into birds, the rules of interaction change. Some of the birds are flying the right way up, some of the birds are going the wrong way up. They're all still very connected. So that is a metaphor for what happens at that interface between order and chaos. That's a region of high order, and there's a transitional phase. So we don't have to go into that, because that's too many words again. But I would like to say about it is that in that the really important thing is that in that interface region, that is where those novel ideas can emerge. Same is true in a society. A society that is too ordered, too structured, is not going to be interesting. We've seen examples of societies that are too structured, too rigid, and we've seen examples of societies that are too far the other way, when they're anarchistic. There's a delicate interface between those two things. And the key thing that is basically maybe a take-home message is that what keeps things interesting, what keeps them to be dynamic systems, is interaction. Is the fact that you have many different building blocks interacting all the time. And that is the hallmark of any interesting system, whether it be my little boat building blocks or people in a community interacting all the time. And I said to my friend Estelle Rosinski, who's sitting over there, I'm going to use her as an example tonight, because Estelle is an amazing art curator and bringer together of very different cultures and artists to do kind of group artworks. And I said to her, I've worked you out. You're not magic. You're just a great example of this. You make all these interactions happen. That's your magic. So that pretty much sums up what I want to say. Other than, just quickly drew up this model. We are basically on a chaotic march from chaos. This is what to order. This is our continuum. And I think what keeps us We long for structure, and I think that longing for structure is what creates our faith. I think faith is created by a longing for structure. And doubt doesn't seem like a nice thing at all, but doubt is extremely important, because doubt kind of makes you take a step back. If you just have faith, say, hey, you know, there's something out there, you're going to fall off the edge into chaos. Doubt is the kind of modulator of your faith. So next time you're feeling doubtful, look at your doubt and say, okay, what are you doing here? Maybe you've got something to tell me. And that bridge, basically, this tower of boats, I call that uncertainty's hinge. Because that uncertainty, that things kind of teeter on, it's a scary place, but it's also a magically beautiful place. And yeah, that's just my closing slide. So yeah, that's really what I wanted to say. I think that sums it up. The take-home message, I said, lots of building blocks, and that allows you to play at that interface. And yeah, that's actually all I have to say.